In your calculus class, you might be asked to find where we have certain horizontal asymptotes of a function. Now, I'm going to be honest with you. This is actually a pretty easy thing to do. We just have a few cases that we need to look at for our functions, right? So what do I mean by that? Well, as you can see, case one, what if the degree of what we have in our denominator is greater than the degree of what we have in our numerator? So say we have something like this. Here, let me pick a nice color for you. We're going to do green. Okay, so what if we had f of x is equal to 3x squared plus 5x minus 4. Sure, that's just a random whatever. And then our denominator is, let's see, x cubed minus 7. Okay, so as we could see, the highest degree in our numerator is 2, and the highest degree in our denominator is 3. Therefore, the degree of the denominator is greater than the degree of our numerator. All right, so we've reached case 1. Now, what does this mean? Well, it means that we are going to have a horizontal asymptote. So we're going to call a horizontal asymptote. Let me just write this out. Horizontal asymptote at y equals 0. So anytime we have the degree of our denominator being greater than the degree of our numerator, there will be a horizontal at y equals 0. And if you don't believe me, you can plug this function into a calculator, graph it, and see for yourself. Now, that was pretty simple. So let's move on to case 2. Okay. Case 2. The degree of our denominator is less than the degree of our numerator. So let's make up another function. F of x, we'll say random number 7x cubed plus 5, sure, plus 5, over x plus 1. There we go. And as we can see, the degree of our denominator is only going to be 1, is less than the degree of our numerator, which is 3. So what happens here? Now, this is actually an interesting case. So we sandwich this one in between the two easy ones. That way we can make it seem like they're all easy. Here, we don't actually have a horizontal asymptote. We have a slant asymptote. Now, what does that mean? You know, a slant could be a perfect diagonal like that, you know, or it could be like that or like that. So how can we tell what is this line? What is the line of our slant, right? And we find this by finding the quotient of our numerator and our denominator. So what you would do to find the equation for our slant asymptote, you would do, we're going to do some long division here, kicking it back to like 3rd grade. 7x cubed plus 5, and then divide that by x plus 1. Now, I'm not going to do this because we don't learn this in calculus. You'll learn in pre-calc, so hopefully you should know it by now. But whatever you get for your quotient is going to be the equation of our slant asymptote. And don't worry about remainders. It doesn't matter if you have a remainder. We're just looking for our quotient. So that's, I guess, the most complicated case of R3, the one most people will probably mess up on. But hey, at least you know how to do it now. So what is our third and final case? Well, we've done less than, we've done greater than, and now we're going to do equal to. Ooh, I know. So what if the degree of our denominator is equal to the degree of our numerator? And I love this one. This one is super nice, right? Let's write our function. We're going to call it, let us say it's 3x squared plus 5 over 2x squared minus x plus 7. These are completely arbitrary, by the way. I'm literally making these numbers up as we go. But as you can see, the degree of our numerator, 2. And the degree of our denominator is 2. And last I checked, 2 is equal to 2. So we have reached case 3. And what do we do in this case? It is super duper simple. We are going to have a horizontal asymptote. Now you're going to have to bear with me as I write this again. I'll try to write it fast. Horizontal asymptote at, do we have any predictions? It is going to be at the quotient of our leading coefficients. Now, those are big words, but stay with me for a second. Our leading coefficients are going to be the two constants in front of our x squared, so 3 and 2. So we're going to have a horizontal asymptote at y equals 3 over 2. Very, very simple. And look at that. 4 minutes and 30 seconds have gone by, and we have done 3 cases, our only 3 cases, to find where horizontal asymptotes are located in functions. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.